This is the formula used to solve for the duration of a bond, more specifically, Macaulay duration. No, it's not your imagination. This is one ugly formula. In this formula, N represents the number of periods until the bond matures. C represents cash flow, so C sub T represents the cash flows that are expected to occur in the future at time period T. In our formula, I represents the yield to maturity for the bond. In the denominator, we have the sum of the present values of all of the future cash flows. This is the bond price. In the numerator, each one of those future cash flows is first multiplied by the period in which the cash flow occurs. Then those values are discounted at the yield to maturity and summed. I see two real advantages of this formula. The first one is that it really does highlight the fact that duration is, by definition, a time-weighted payback. It shows us that the duration of a bond is a time-weighted payback with each future cash flow weighted by the year in which it occurs. It really does give us an idea of how long it takes to be paid back for our initial investment in this bond. Second, and most importantly, however, is that it really helps us appreciate the next duration formula, which is much, much simpler, and the recommended approach when solving for bond duration. I just don't believe that you should use this formula to solve for bond duration under any circumstance. Now, while this is a scary looking formula, it's truly not that bad. It's not time to panic, folks. Just be able to plug in the appropriate variables and then carefully perform the mathematics. The three variables represented in this formula are the three variables that impact bond duration. C is the coupon rate, Y is the bond's yield to maturity, and T represents the time to maturity. York Industries has an outstanding bond issue with the following characteristics. $1,000 par, 8% coupon paid annually, 20 years to maturity, and the bond is priced to yield 11%. Calculate the duration of this bond. Well, let's write down our formula. Bond duration is equal to 1 plus Y divided by Y minus 1 plus Y plus T times C minus Y divided by C times 1 plus Y raised to the T power minus 1 plus Y. We have all our variables. Let's just plug it in. Duration is equal to 1.11 divided by 11% minus 1.11 plus 20. Our coupon rate is 8% minus 11. In the denominator, we have our coupon rate of 8% times 1.11 raised to the 20th power minus 1 plus our yield to maturity of 11%. 1.11 divided by 0.11 gives us 10.09 minus, in the numerator we have 0.51, in the denominator we have 0.675, giving us a duration of 9.33 years. Hudson Agriculture Products has an outstanding bond issue with the following characteristics. $1,000 par, 6% coupon paid semi-annually, 11 years to maturity. This bond is priced to yield 8%. Calculate the duration of this bond. Well, since this is a bond that pays interest semi-annually, then we're going to have to make a few adjustments. First, let's determine what is the semi-annual yield on this bond. Well, if it's priced to yield 8% annually, then the semi-annual yield is 8% divided by 2, which is a 4% semi-annual yield. We need the number of periods. Well, since it is 11 years to maturity and it's semi-annual, that's going to give us 22 total periods. And the semi-annual coupon rate is going to equal the annual coupon rate, 6%, divided by 2, which gives us 3%. Okay? Well, let's write down our formula. Duration is equal to 1 plus y over y minus 1 plus y plus t times c minus y divided by c times 1 plus y raised to the t power minus 1 plus y. Our semi-annual yield is 4%, so we have 1.04 divided by 0.04. In the numerator, we have 1.04 plus the number of periods, which is 22, times our semi-annual coupon, 0.03, minus the yield, divided by the coupon rate, 0.03, 1.04 raised to the 22nd power minus 1 plus our semi-annual yield of 0.04. 1.04 divided by 0.04 gives us 26. In the numerator we have 0.82. In the denominator we have 0.081. Giving us a duration of 15.877 semi-annual periods. If we take 15.877 and divide it by 2, it's going to tell us duration in years, which is 7.9 years.